Okay, hello, good morning, students. How are you today? Okay, I'm glad that all of you are healthy and happy today. So, today we are going to continue our lesson. Today we are going to talk about mathematical logic. So, after this class, I hope you all be able to identify and distinguish between open sentence and closed sentence or statement in mathematical logic. And then the second, you are able to explain and apply logical operations such as conjunction, disjunction, implication, biconditional, including their negation and truth values. And for the last, I hope all of you will be able to use the rules of logical reasoning such as modus ponens, tollens, and syllogism to draw valid conclusion from mathematical statement. So today's topic is quite full. So we are going to talk about seven topics. The first is open and closed sentences. Second is quantifier. The next is negation, compound statements, logical operation, equivalence, and drawing conclusions. So let's start. The first is about mathematical logic. So, what is mathematical logic? So, mathematical logic is defined as a branch of mathematics that deals with the study of formal reasoning using symbols and rules to determine the truth value of statements and validity of arguments. So, let's take an example. So for the example, think about how courts of law works. A judge does not just decide based on their gut feelings. They follow a logical structure. If the evidence proves X and X leads to Y, then Y must be concluded. So that's all about mathematical logic. So next we are going to continue about open and closed sentences. So what is that? What is sentences in mathematics? So open sentence is defined as a sentence that contains one or more variable and whose truth value cannot be determined until those variables are given specific value. And meanwhile, the closed sentence is or also can be called as proposition or statement is defined as declarative sentence that has a definite and fixed truth value either they are true false but never both at the same time. So in other words, the key difference between an open sentence and a closed sentence is whether their truth value can be determined right now. An open sentence depends on a variable. Without knowing the variable's value, we can say if it's true or false. A closed sentence, on the other hand, stands on its own. You can immediately evaluate it is as true or false. So note for all of you guys, questions, comments, exclamation are never a proposition because they don't make claims then that can be true or false. So Okay, for close and open sentence, I have some example for you. Can you guys determine which one is closed sentence and which one is open sentence? Or okay, so who gonna answer this? Okay, Anna. So your answer is okay. So you say this is close, open, and close. Okay, let's see the answer. Okay, so the answer is the one with the pink color is an open sentence. And the rest of that is a statement or proposition or closed sentence. Okay, so let's move to the next topic. So the next topic is about quantifiers. So what is quantifier? Have any of you heard about quantifiers? No? Okay, let's see what's the definition of quantifiers. So, a quantifier is defined as a symbol that used to express how many elements in a given set satisfy a particular open sentence, effectively turning an open sentence into a proposition. So, there is two types of quantifiers. There are universal quantifier and essential quantifier. So, in other words, quantifiers are tools that given a scope to an open sentence. They tell us whether a property applies to every element or just some element in a set. Okay, so let's first we are going to talk about universal quantifier. So universal quantifier has a symbol of an upside down A. So this notation means for all. So for all P of X means the property P holds true value every single element X in a given set. It is true if no element makes P false, and it is false if even one element makes P false. And next is essential quantifier. So the symbol is E, but it's still yeah upside down. And the notation can be can be read as there exists an X such that P of X mean at least one element X satisfies the property of P. So it is true if at least one element makes P true, and it is false if no elements makes P true. So for the example, okay, let's take a look for the easy example. For universal quantifier, every student in this class has a phone. So it is universal for everyone. And the next is for essential quantifier. There is at least one student in the class who owns a car. So this is essential because this is not for everyone. But we have at least one student that owns a car in that class. Okay, let's move to the more mathematical example. Okay, let the set B as equals to 1, 2, 3, 5, 1, 2, 3, 4, 5. So for all x element S, such as x greater than 0 is true because every element on the set X is greater than 0. So this is true. And for the next, for all X element S, such as X greater than 4, this is all. This is false because not every element S is greater than 4. Okay, so let's move to the example of essential quantifier. So the first is there is exists an X element S such that X greater than 4. Can anyone of you explain to me why this is true? Okay, Christoph, you want to answer? Okay, so your answer is correct. This is true because there is exists just one, but at least one element in S that is greater than 4, which is yes, 5. So it's the same for the next example. Okay, let's continue to our topic. Okay, the next topic is about negation. So what is the negation? Does anyone know the definition of negation? Anna? Okay, that's good. So, negation is defined as logical operation that reverse the truth value of a proposition. So, the negation of proposition P is written as not P. Okay, you can see the symbol on the screen. So, I also have the truth table for the negation. So, if P is true, then negation of P is false. The other way, if P is false, then the negation of P is true. So, in other words, if P is true, then not P is false. And if P is false, then not P or negation of P is true. So negation is simply just flips the truth value. So for the example, okay, so P is so statement we have statement P that says today is Monday and the truth value is true. So the negation will be today is not Monday and negation will be and the value will be false. So for the next example is the same. Is this is a negation for quantifier that we are already learned earlier. So this is so do you understand this example? Okay, good. So the first one, the P is true, and then the negation P must be false. Okay, let's move to the next topic. Okay, so the next topic is about compound statement. So compound statement is defined as a statement that formed by combining two or more propositions using logical connectives. So, in other words, a compound statement takes a simple propositions, each with their own truth value, and connects them using specific logical operation. Okay, the true value of the compound statement depends on the truth value of the individual propositions and the connective used to join them. So we are going to learn about four main of logical value. There are conjunction, disjunction, implication, then biconditional. We will look at each one in very detail in the next section. Okay, so the next section will be logical operation. So first, we are going to talk about conjunction. Okay, so the definition of conjunction is defined as a compound statement formed by connecting two propositions P and Q with the word L, symbolized by, you can see the symbol on the screen. And I also have the truth table for conjunction. So if P is true and key is true, so P and key is true. If P is true and Q is false, then P, P and Q is false. Next, if P is false and Q is true, then P and Q is false. And if P is false, if P is false and Q is false, then P and Q is also false. So in other words, a conjunction is true only when both provisions are true at the same time. If even one of them is false, the entire conjunction is false. So let's take a look at the example. So we have the P statement such as the light is on, the truth value is true, and the Q is the fan is running, and the truth value is true. So P and Q will be the light is on and the fan is running. Okay, so based on the table of the truth table, the value of P and Q will be true. The same goes for the for the mathematical example. Can any of you guys explain to me why this example become like this? Okay, Hans, can you answer? Okay, that's true. So the P, if the statement P says egg is an even number and the value is true, and Q say egg is a prime number, then Q, P and Q will be egg is an even number and egg is prime number. This is false because the Q is false, so their conjunction will be false. Next is about the second is about disjunction. So disjunction is defined as compound statement formed by connecting two propositions P and Q with the word or. Okay, you can see the symbol is here. And I also have the truth table for disjunction. So if P true and Q true, P or Q will be true. P true and Q false, P or Q will be true. P false, Q false. Okay, I'm sorry, this is wrong. I mean Q is true, then P or Q will be true. And the last, if P is false and Q false, P or Q will be false. So, in other words, a disjunction is false only when both propositions are false. As long as the least one of them is true, the disjunction is true. Okay, let's take a look at the example. Okay, the first example will be if P is statement such as I will take a bus, and let's say it is false because I miss it. And the Q is I will ride my bike. And the value is true. And the disjunction will be I will take the bus or I will ride my bike. Okay, the value will be true based on the truth table. So for the other example is okay, let's say P is 3 plus 3 equals 9. This is false, right? Okay, right. So the Q will be E is an odd number. And the value is okay, true. So their disjunction will be 3 plus 3 equals 9. Or 3 is an odd number. Okay, this is will be true. Okay, let's move to the next. Okay, next we have implication. Implication is defined as compound statement of the form if P then Q, symbolized by this arrow. Okay, as you can see. So implication have three variation. The first is converse. Converse formed by switching the position of hypothesis and the conclusion. So this is what we call converse. If Q, then P. Okay, the second variation is inverse. Inverse obtained by negating both statements in the implication without changing their order. So the inverse will be if not P, then not Q. Next, the contrapositive. The contrapositive created by reversing the implication and negating both parts. So it will becomes not Q. If not Q, then not P. Okay, so this is the truth table of implication. So you can see for a while the table. Okay, so in other words, an implication say whenever P is true, Q must also be true. The only way implication is false is when the hypothesis is true, but the conclusion fails or false. Okay, let's move to the example. Okay, so the example is the statement P, you finish your homework is true, and you can go out and play is also true. So their implication will be if you finish your homework, then you can go out and play. So the truth value of this implication will be true. Okay, this is the same for the next example. Okay, let's move to the last operation. That called be conditional. Be conditional is defined as compound statement if of the form P if and if only Q, symbolized by this double arrow. And I also have the truth table of be conditional. Okay, if P true, Q true, be conditional will be true. If P true, Q false, be conditional will be false. P false, Q true, be conditional will be false. And the last, P false, Q false, the conditional will be true. So in other words, a biconditional is true when both propositions have the same truth value, both true or both false. It is false when the true proposition have different truth values. Okay, let's move to the example. Okay, I have example. The first example is if P is I get paid and Q is I go to work. So the B conditional will be I get paid if and only if I go to work. Okay, let's take a look at the other example. So if P is x squared equals 9 and x greater than 0 and the Q is x equals 3, the B implication will be x squared equals 9 and x greater than 0 if and only if x equals 3. So this B implication has the truth value true. Okay, let's move to the next topic. Okay. Okay, the next topic is equivalence. Okay, as any of you have heard about equivalence? Okay, maybe you have heard about that. So in equivalence, we have three main topic. That is tautology, contradiction, and contingency. So a tautology is defined as a compound statement whose truth value is always true, regardless of the truth value of its component proposition. And, and the next contradiction is defined as compound statement whose truth value is always false regardless the truth value is component's proposition. And the last about contingency, contingency is defined as a compound statement that neither always true nor always false. Its true or values depend on the truth value of its component. So, in other words, I can make a conclusion a tautology is a statement that is always true, no matter what. And a contradiction is a statement that always false. And the last contingency is anything between them, sometimes true and sometimes false. Okay, let's take a look for some example. Okay, the example one is for tautology. The example is tomorrow I will go to school or I will not go to school. This statement is always true because it includes all possible situations. Either you go to school or you do not go to school, so one part must be true. So we already run before if or in the disjunction if the other proposition is disjunction is true, the truth value must be true. So the next example is about contradiction. Can anyone explain to me why this example, I'm sleeping and awake at the same time, is contradiction? Okay, Anna? Okay, okay, good answer. So this statement is always false because someone cannot be sleeping and awake at the same time. And the last is contingency. The example is I eat fried rice today. So this statement can be true or false depending on the actual situation. So its truth value is not fixed. Okay, let's move to the last topic. The last topic is about drawing conclusions. So what is drawing conclusion, guys? Okay, so drawing conclusion is defined as process of verifying a new proposition called conclusion from a set given proposition called premise using valid logical rules. So, a conclusion is valid if the argument form when expressed as premise 2 and premise 1, and conclusion produce a tautology. So, there are three standards of interference value. The first is a modus ponens. So modus ponens is defined as interference rule that state if P then Q is true and P is true, then Q must be true. So in other words, if you know if P then Q and you also know that P actually happened, then Q must follow. The premise is confirmed and the conclusion is guaranteed. For example, so premise one is if x is divisible by 6, then x is divisible by 2. And premise 2 is x equals 18 is divisible by 6. So the conclusion will be x is x equals to 18 is divisible by 2. So this is, okay, this is the P, this is the Q, and we know the P, and the conclusion will be the Q. Okay, next. Okay, next we have modus tollens. So modus tollens is defined as the interference rules that states if P then Q is true and Q is false or negation of Q, then P must also be false or negation of P. So in other words, if you know if P then Q, but Q did not happen, then P could not have happened either. It works ruling out the cause through the absence of the effect. So for the example, if premise 1 is if n is a prime number greater than 2, then n is odd. Okay, this is the P and this is the Q. So the primes 2 will be the negation of this. Then n is odd. Okay, if n equals 8 is not odd. So we have the conclusion n equals 8 is not a prime number greater than 2. So okay, let's move last to the last drawing conclusion is about hypothetical syllogism. So hypothetical syllogism is defined as interference rule that states if P if P then Q and if Q then R are both true, then if P then R must also be true. So in other words, if P leads to Q, and Q leads to R, then P leads all the way to R. This is chain of implication. The middle term Q links the two premises, and we can skip over it and connect P directly to R. So this is for the example. So the example is I have premise 1 that say if a number is divisible by 9, then it's divisible by 3. This is P and this is Q. So the premise 2 is say if a number if A is a number divisible by 3, then the sum digits is divisible by 3. This is the Q, the same as this, and this is the new R. So we have the conclusion: if a number is divisible by 9, then the sum of its digit is divisible by 3. Okay, so this is the conclusion of this syllogism. So that's all what we learned today, guys. We already learned so much today, and I thank you for your attention. See you on the next class. Goodbye and have a nice day.